The Energy Dialogues is a series of podcasts from EnergyNow that showcases companies, events, and topics that are part of our energy industry. Today's Energy Dialogue guest is Stephen Winkler from Quantum Downhole Systems. And now, your host for today's Energy Dialogue, David Yeager.
Well, look, let's just kick it off, Stephen. Welcome to Energy Dialogue. Thanks for coming in today. You and I have a little bit of a history, as is well known.
Yep.
Going back a little ways. So I think, I think part of the things I think people ought to know is the people behind the company. So
Yep.
where the heck did Steve Winkler come from, and how did you get from where you were to where you are?
Well, started out on a farm.
Okay.
So farm boy, east central Alberta, mixed farm. Right from being a baby, and graduated high school, local town, of course.
Which town?
Graduated out of Elk Point.
Okay.
Middle of heavy oil country.
Yeah. I remember that. Yeah, right in the middle of it all. Yeah.
So and then I went to work for a BMW, which was a pump supply company out of Elk Point.
They were the screw pump guys.
Yep.
Yeah.
Progressive cavity pumps. We did the first tubing pumps in the first SAG-D wells that were in northeast Alberta. I was a pump technician, so reviewed thousands of pumps, PC pumps. We're diagnosing issues and problems. And then we ended up getting purchased by Energy Ventures, which is Weatherford, over time, and that was a really good thing for that company. And a couple of years later, I ended up starting with Untitled, which obviously turned into IPS, and spent 8.5 years from start to finish with that company, doing various types of jobs, optimization.
But I mean, that's where you started out, was optimize, because I'm leading into something with these questions.
Yeah.
Because you're still in optimization in
Essentially.
a way. Yeah, essentially, you're still in artificial lift and fixing wells.
Yes.
So you started out with Otatco as a...
Well, it was tool. Wasn't really a tool hand, but started out with as an optimization technician, doing dynamometers, depression tests, and fluid levels, and then also some regulatory type work with surface casing vent flow testing.
Okay.
And, all of those types of things on typically pumping oil wells.
Right.
Yep.
And then came to Calgary, right?
Yeah, with Otatco, a year later, less than a year, they moved me to Calgary, and then I got exposed to some downhole tools, cased hole wireline, wellhead intelligence through Menex, and various different things there. Yeah,
so I just want the reason I say this is your entire career has been in making wells produce better.
Exactly.
Really, if you look at every aspect of it.
Pretty much.
Yeah, okay. Yep. So where did the quantum concept come from?
So after my days at IPS, I was working on a project for Encana, actually. They were having difficulties lifting water of condensation from really low bottom hole pressure Horseshoe Canyon wells. And so they're from various groups asking me about different concepts and ideas about how to get this water out of these wells, because it's impeding the inflow of the gas.
Right.
And swabbing wasn't really working effectively. Conventional coil tubing wasn't working effectively, so they wanted a different method to get this water out of the well, basically with the negative pressure. Well, they didn't say that, but in my mind is one day at a set of traffic lights, which is the old story, it just popped into my mind to put an artificial lift system on coil tubing. And it was the hardest drive home I've ever had to make, because I couldn't tell anybody about it.
Well, hang on. Now, are we in the horizontal era yet?
No,
okay.
This is back in 2009 when gas prices, commodity price of gas was still pretty good.
Okay.
And so even though the wells were quite cheesy and low productivity, they still could spend some money on them.
Okay.
We had a boiled down solution fit for purpose on the shallow gas, because that's what we started on. And but however, within about a year, the shale gas revolution was starting to take place. Thanks to some Calgary development, and the commodity price decreased, and then oil started to come into play, and the horizontal multi-frac oil wells really started to become the new flavor of the next years.
So what did quantum system number 1 consist of?
For the oil.
For the gas.
Okay.
You said you said you were putting artificial lift on coil as a way to dewater low pressure. Negative pressure or low pressure.
On an intervention basis.
Yeah. Okay.
Yeah. So I looked at because I had an artificial lift background, but I didn't have any coil background.
Right.
I kind of started with what artificial lift systems that I knew of that would maybe possibly work in an application like this. So I looked at progressive cavity pumps ran by electric. I looked at electric submersible pumps. One of the ones that I didn't know much about was jet pumps, and that is actually the one that we ended up with.
All right.
So through my travels and talking to various people, I got introduced to the jet pump technology and got convinced of it. And that was the first system that we started, was as a multi-string spoolable coil tubing, essentially, which allows us to pump fluid down one coil through a hydraulic tool, which creates vacuum and an artificial lift, and the returns go up the other coil.
Right. That was parallel tubes, right?
That's right.
Yeah. Okay.
Yeah, exactly. A little bit different configuration than now, but allowed us to execute the jobs,
Right.
prove up the process,
Okay.
and move into commercial, which soon happened.
And again, what year was that?
That was in 2009.
Wow.
We started operations June 15th of 2009. Which
We
is
got an
right around the
anniversary
corner.
today.
Yeah, exactly.
Cool. All right. And then, okay, so this gas goes down, oil goes up. You're a heavy oil guy. You know all about sand.
Yep.
And artificial lift optimization. What would be the next major technical step for the technology?
So back to the gas, just to set that stage just a little bit, is essentially we were going down there with a vacuum tool, jet pump just sucking, and we'd go down and we'd vacuum that water out until there wasn't any water left in that well, and we could tell based on the returns.
Right.
So all of a sudden we'd be gas in the returns,
Yep.
boom, the well is pumped off, and we can pull out a hole, move to the next well, and continue on. So in a horizontal environment where we knew we were going to, is we had to readapt the tools, which kind of made some jets on the bottom to stir up the sand, because we couldn't.
Okay,
just,
so the next step in
Yeah.
cleaning things out is just to get it in order for those that don't
Yeah.
have the background that you and I do.
Yeah.
Instead of cleaning water out of low productivity gas wells, we're going to start cleaning sand out of questionable activity oil wells.
Exactly.
Okay.
Just a little engineering 101 is that it takes 3 times the energy to move a sand particle horizontally versus vertically.
Yep.
So that means you need 3 times the volume, 3 times the velocity to keep that sand particle moving.
So you got to rebuild the whole assembly. Rethink
This is
it.
from a production scenario.
Yeah,
What happens is that these wells, obviously, if you're pumping tons and tons and hundreds of tons of sand into these wells, that it is likely that a little more than a 5-gallon pail full of sand is gonna come back into the well bore.
Yeah.
And the velocities obviously are lower than the transport velocity that is required to keep sand moving.
Okay.
So bridging, impermeable sand bridge form in these wells.
All right.
It is inevitable.
Now these are fracked wells, or are these just chops wells, as you call them?
That's a very that's a quite a loaded question.
There's 2 ways
Yeah.
to get sand in there. You can
Yeah.
put it in, or
Yeah.
it can come with a reservoir, right?
That is exactly right. Those are kind of the 2 areas that we work in is horizontal multi-fract wells, where sand is placed
Right.
into these wells, and it's some of the problem wells where the sand doesn't stay in place does flow back, and we do vacuum that out. And then there's the other aspect, which is the oil sands, I guess, SAGD, cyclic steam,
Right.
and chops,
Okay.
which is for those again on the technical side. Chops is cold heavy oil production
Yep.
with sand, and so purposefully producing sand in a under pressured lower type productivity well intuitively has some concerns and issues with continuing to keep that sand moving throughout that lateral.
Yeah.
And keeping that lateral open, so you can produce oil from that entire length of interval.
But just to go full circle on
Yep.
this interrogation, that's really where you started.
Yeah.
Was with sand, right?
Yes.
Conventional heavy oil producing sand.
Yeah.
Right
that's
on.
right.
Right on. Okay, so when do you think you got your system to the stage it's at today? I mean, there was R&D and reinvestment
Yeah.
and so on, and so when do you think we got that component of your product
Right.
line to what we have today?
Yeah, so you kind of call it a technology curve, so to speak.
Yep.
Is that the Google, when they started, certainly isn't the Google of today.
No.
And nor was Quantum, and so it really took us. We've been in business now for 8 years. It took probably 6.5 of those to get to where we have got the solid strong, repeatable technology that we
Okay.
do today. It really
Okay.
took that long. We're an undercapitalized company. We're a small Canadian private company. Not that is too big, but that does hinder your development on the R&D side. But over the last year and a half, I would say, is we've got that really strong repeatability.
Okay.
We're gaining customers and repeat customers as well.
Now, you had to deal with the volumes that you're dealing with. You kind of had to reinvent that jet pump, didn't you?
Yeah. So our earlier system, just to go back to that for just a second, was really quite small and didn't handle as much sand, or it didn't lift as much, just volume out of the well. And so what one of the big breakthroughs over this past year and a half was redevelopment of the coil tubing. So we're using a concentric setup now,
Okay.
which is one coil inside the other.
Yeah. Okay.
So that allows us to optimize the hydraulics of the system.
Okay.
Okay, because it's a friction system. And then what we did is because we knew we could increase the volumes, effective horsepower through the tool or through the coil, is we redeveloped the jet vac tool. And so that's now allowing us to lift well in excess of 100 to 150 cubes of fluid or volume equivalently out of a well in 24 hours, which before that we were a fraction of that volume. So that allows us to do these wells quick and economic, and gather some really good accurate data, because we're seriously underbalanced while we're doing some of these jobs.
The uniform diameter, external diameter coil probably makes more flexible, and who can run your stuff too.
Yeah. It opens up conventional. Coil has been known for probably the last 15 years as to be one of those really, really future emerging technologies, right? Service rigs have been around, conventional stick pipe drilling rigs have been around forever, but coil tubing, because these wells are so long, and the downhole tool industry to support the coil has grown, phenomenally over the last 10 years. Is that it really is, the Swiss Army knife of the oil patch, and it's allowed the operators to do many things on these wells now that they couldn't do many years ago. But that's development.
But you don't own the coil. You're just running the tools.
That's right. We own the string.
Well, no, sorry. You don't own
the
the coil tubing unit. Is what I meant.
That the tools are deployed on, but we're not. So we're really what we do pride ourselves on is you kind of the experts, I guess. Below the wellhead. Yeah. Understanding the reservoir.
Where the action is.
And the interaction with the wellbore. That's really where we focus.
Yeah, well, that's your entire history post agriculture.
Yeah.
Or post high school. So look, you've got two other different applications. Of what we'll call horizontal well optimization, and let's run through those.
Sure. We had, as we started to gain a fair amount of traction in the cleanout industry, is we started recognizing that, and as these wells started to mature, these horizontal multifracs started to mature, is that they weren't producing quite as effective as they should. So the clients were asking us, can you clean these wells? However, one of the biggest completion methods in the probably the first half or 75% of the horizontal multifracs are these open hole pack or ball frac systems. And fortunately and unfortunately, many of the producers haven't milled those balls, the remaining balls.
They left the seat in there.
And the seats are in those
Yeah,
wells.
yeah.
Right? And that evolution has changed a lot over the last couple of years as well. But there is a lot of wells out there that are now depleted in pressure that have some balls left in there that are not degradable, but also these mechanical sleeves. And now they're seeing a abnormal decline or overall productivity on these wells that is not meeting the type curve of the reserves. And so they want to intervene these wells. So what we did is we noticed this, and we had clients coming to us and asking us. And so we seen a little bit of a weakness in the current system. So we developed this dual coil milling system. And it uses our existing concentric dual coil that we have.
Right.
And essentially what it does is allows us to improve that milling process on these super under pressure and depleted wells, so that we can open that well for the client, clean that well for the client, so they can make next steps, whether it's a refrac, water shut off, you name it, re-stimulation.
But I mean, the beauty of this system is as you're creating new debris,
Yeah.
which is really what you're doing, right?
Yeah.
When you're drilling out scale or drilling out these seats or something, you're actually creating more garbage.
Right.
And
yeah.
the idea that you've got it on this negative pressure return, make sure it goes out of the well instead of into the well.
Yeah, we get some clients saying now that we're milling blind and drilling blind and stuff, which means that you're not getting returns.
Yeah.
And when you're putting a 2-inch pipe or a 2 3/8 pipe inside a 4-inch diameter, and you've got sand down there, it can be a disaster, like a big disaster. And so what we've done is we've made that ability for these clients to effectively, safely, economically mill these wells and open them for future intervention.
Well, you want to clean them, not plug them.
Yes. Yeah.
Okay.
Yep.
That's patented as well.
That is a patented system for quantum only, and we're exploiting that and using that in Canada and in the U.S.
Now you have one more application
Yeah.
of your dual coil.
Yes.
And the same general technology. What's that?
Well, that kind of gets into the clouds, and a little bit of a bigger picture is that we've got a system to open the well, clear the well of scale, debris balls and seats and whatnot, a system to clean the well, but also we have a modification of the jet vac, which we call a Q vac.
Okay.
And so what that is the jet vac essentially with the jets on the leading edge of the tool shut off. So again, it's back to just vacuuming.
Okay.
And so what we do is it creates a localized drawdown at the tool, and we pass this tool across all of the ports or the producing intervals in the well.
Okay.
And so the return data that we get out of the tool, coupled with the downhole pressure and temperature sensors that are also in the tool.
Oh, they're built right in. Yeah.
Yes, is we can put together a dynamic picture of actually what's happening on kind of an individualized component or producing interval of that well.
You mean the entire drain hole?
Exactly. Yes. So what is producing, how much, and what type of product is it producing? Is it gas?
Yeah.
Is it only water, or is it a high producer, or is it not producing at all?
Yeah.
So these are very serious assets for these clients. Somewheres of $6 to $10 to $12 million sometimes.
Yeah.
And they can't production log them with current methods because they don't flow.
No, I think that's the one thing we should pause and say is that you've got a 1 kilometer, 1.5 kilometer drain hole in a reservoir. If it had great pressure, you wouldn't have to drill it horizontally.
Yeah.
And one of the great mysteries is what sections of this drain hole are productive or not productive, what's plugged, what could flow, what isn't flowing.
Exactly.
And that's really where you're going with
Yeah.
it.
Yeah, and kind of the big picture of the QVAC and some of our future, goals is that we really want to capture this data, and really what it is there's the low level part of it is, clean my well, open my well so I can produce my well,
Yeah.
cumulative thing. But on the other hand, the real prize with the QVAC is gathering this data and this accurate data, so that the oil companies can take this data back and process it at a high level, right, with petrophysiology and the geologists, the reservoir guys.
All right.
So when they future drill these wells, they actually know how much oil that they can get out of this reservoir realistically versus what the current models, which we don't really know where the algorithms have been built on, is really how much oil can we get out of this rock.
Well, it took half a century to perfect vertical well optimization techniques. So you're on the cutting edge of the horizontals. There's thousands of these things in there.
There is. And that's kind of the part is it's a mechanical solution, but it's also a solution to capture data that can really have a significant impact on the amount of oil that's really coming out of that reservoir.
Yeah.
Yeah.
Where have you worked? You've worked in Western Canada, obviously. You've done jobs elsewhere?
Yeah, Western Canada, North Slope in Alaska.
Okay.
We have done some work in California. We have consistent operations in California, also working in heavy oil.
Yeah.
There's more of a steam flood down there versus a SAGD scenario, which is our primary technology up here in the oil sands for thermal. We've worked in Colorado, Wyoming, and also Oklahoma.
Okay.
Yeah, yeah.
Now,
And Venezuela as well, just kind of in the south side of things as well. We've done some work.
well, they've got quite a bit of heavy oil.
Well, that that it is in my assessment. It's the best heavy oil reservoir in the world, actually.
It is bigger than Canada's.
Bigger, more pure and thicker, and more. There's a lot of resource there.
So you've worked for all the big dogs. You know,
Yes.
your client list is
Very respectable.
very respectable. You've got the attention of the technical departments of the bigger operators.
Yes.
Okay,
Yeah,
good.
yeah, and they're starting to be, over this last year and a half is consistent repeat, business, which is a real breakthrough for us.
Two more really tough questions. You can be at perfecting various elements of this. Like, where are you going in the next few years? Like, you can be adding, perfecting, and building upon this technology platform for a long time.
I think so. I think that the mechanical side of things is we're always going to continue to keep developing that to improve the process.
Okay.
But I think the real value, like from just the industry standpoint,
Right.
is the data. Is
Yeah.
What can we really
Well, no,
do?
in the end, if
Yeah.
it is, I know what you're talking about. I hope our listeners do as well.
Yeah.
And what short-term go-forward plans, medium-term plans?
The short-term plans is we're excited about the Canadian market. I'm a strong believer and have a lot of respect for Western Canadians in their work ethic and the ability to squeeze blood from a rock. And
Or heavy oil, about the same thing, isn't it?
Yeah. We work. The Canadians, we're got a worldwide renowned recognition for providing new technology. Right? Is that we're smart people. We work hard. We have a tough basin to make oil and make profitability out of gas as well. But we make up the difference with our work and with technology. And I think we're going to be competitive on the global scale.
Now, just to wrap up, you've hit some real home runs on a well that was making nothing, and then you charge them a few bucks, and they're coming back. I mean, got any showcase examples of?
Yeah. There is some, and I'll
You don't have to mention the client.
Yeah,
but,
we won't. But I'll just say, kind of, heavy oil is we've kind of knocked some stuff out of the park in the heavy oil, and this is going back 5 years ago before our system is what it is now.
Okay.
Back in it was 2000 and it was fall of 2010 is we did some work up in the heavy oil area on some horizontals on a channel sand play, and we made that well came on higher than IEP after we cleaned it. And it stayed higher than IP for 2.5 years after we cleaned it, and so that is that was a real knockout out of the park. They're not all like that, of course, Dave.
No.
But what we can take away from something like that is that, okay, well, how do we find? It was a pretty big producer, by the way. So from the oil company, the owner of the asset
Was
is
thrilled.
How do we take that knowledge out of that, and how do we find more like that?
Yeah.
That's the thing, right? And that's something we could probably work on a little bit. And then on the multi-frac side is we have cleaned many of these wells where other methods have been tried and failed.
Okay.
A few different methods have been tried and failed, and we've cleaned some of these wells and negative declines on a month-over-month for a year and a half.
Oh, really?
So. Oddly, and we've got the case history to show and will show, is that the production was going up on the well for over a year and a half after we cleaned it, and other methods couldn't get sand and couldn't get circulation on that type of well.
Huh.
Yeah.
Well, it's your company. You founded it. You're a salesman. You're not stuck for words. Just to wrap up, what are the last things you'd like the world to know about Quantum Downhole?
Well, that we're not going anywhere. We're going to continue to develop. We're adding to our sales and marketing group. We feel that it's solid, and we want to get this technology out there and help our partners, which is the producers, really.
Yeah.
Those are our real true partners. Let's work together on using this and exploiting it to make Canada as competitive as it can be.
But just as I recall, just one last question. You actually managed to stay profitable in 2015 and 2016.
Yeah, that was, whether
I'm sure it wasn't easy.
well, whether it was luck or hard work or prudency, I don't know. But
Yeah.
I don't have a business degree. Just farm boy that had an idea and started a company, and with a little bit of training in the back, I worked with some great people over the years, which I'm really fortunate, and so they're part of my development as well. But we remained as an entity through 15 and 16. We were profitable through those years. Maybe not significant growth, but what we did too is obviously we spent a fair amount of money and time and effort on the R&D and improving. We took that as an opportunity and a window to focus on improving the technology, and we think we've got a pretty strong foundation.
Wow.
Pretty excited about many things in the business, actually.
Congratulations.
Yeah, well, thanks a lot, Dave. It's
no sweat.
Always a pleasure.
All right, have a great day.
Yes, you too.
Thank you for listening, everyone. We encourage you to share this broadcast in your social media channels. Until next time, have a great day.